Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation. So let's get going. Problem: solve x squared plus y squared minus a squared into x dx plus x squared minus y squared minus b squared into y dy equal to 0. Check whether it is exact or not. Solution: given differential equation, x squared plus y squared minus a squared into x dx plus x squared minus y squared minus b squared into y dy equal to 0. Consider as equation number 1. Now we can write this equation as x squared into x cube plus y squared into xy square minus a squared into x into dx plus x square y minus y squared into y cube minus b square y into dy equal to 0, which is in Mdx plus Ndy form, right? Mdx plus Ndy equal to 0 form, or which is in standard form, we can say, which is of the form Mdx plus Ndy equal to 0, where M is a coefficient of differential dx and N is coefficient of differential dy. M equal to x cube plus x square y minus a square x, and N is x square y minus y cube minus b square y. We can say that the given differential equation is exact if dou m by dou y equal to dou n by dou x. Okay, that is partial derivative of m with respect to y, treating x as constant here, equal to partial derivative of n with respect to x. So here we'll treat y as constant. Now let's find partial derivatives of m and n. We have m equal to x cube plus xy square minus a square x, and n equal to x square y minus y cube minus b square y, right? Now we need to find derivative or partial derivative of m with respect to y and partial derivative of n with respect to x. We'll begin with partial derivative of m with respect to y, treating x as constant. Right? Dou by dou y of m, x cube plus xy square minus a square x. Since it is a partial derivative with respect to y, so x will be constant, right? Here x cube x a square x is a constant. So we can write this as dou by dou y of x cube plus dou by dou y of xy square minus dou by dou y of a square x. This equals to dou by dou y of x cube. Here x is constant, so we can write second term as x into, that is constant, into derivative of y square minus, both are constant, so just write as it is. Okay, fine. Derivative of a constant with respect to y is 0. Since it is a partial derivative with respect to y, so we'll treat the remaining variables as constant. So here x is treated as constant and a square is also treated as constant. So you'll get derivative of a constant with respect to y is 0 plus x into derivative of y square with respect to y is 2y minus derivative of a constant with respect to y is 0, which is equals to 2xy. Therefore, partial derivative of m with respect to y is 2xy. Let's now find partial derivative of n with respect to x. So here we are finding partial derivative of n with respect to x, so we have to treat y as constant. Okay, treating y as constant. This is equals to dou by dou x of n, x square y minus y cube minus b square y. We can write this as dou by dou x of x square y minus dou by dou x of y cube minus dou by dou x of b square y. So here y is a constant, so let's write the first term as constant into partial derivative of x square minus, I'll write the remaining two steps as it is, right? We can just avoid this step. We'll get y into derivative of x square with respect to x is 2x minus derivative of a constant. Since it is a partial derivative with respect to x, so y is treated as constant, so y cube is constant here. So derivative of a constant with respect to x is 0 minus, here b square is constant and y also constant because it is partial derivative with respect to x, right? So partial derivative of constant with respect to x is 0. This is equals to 2xy. Therefore, partial derivative of n with respect to x is 2xy. Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x equal to 2xy, right? Therefore, dou m by dou y equal to dou n by dou x. Since dou m by dou y equal to dou n by dou x, therefore, the given differential equation or equation 1 is exact, right? And we know that the general solution of an exact equation we are given an exact equation, right? Exact equation. How we are saying that the given differential equation is exact equation, since dou m by dou y equal to dou n by dou x. Since this shows that the given differential equation is an exact equation, right? Fine. Now coming to the general solution formula. The general solution of an exact equation is given by integral Mdx, y is treated as constant here, plus integral n, that is terms of n free from x into dy equal to c. Okay, so let's find integral m dx, where y is treated as constant, and integral n terms of n free from x dy separately. And finally, we'll come to the general solution. Using this formula, we can find the general solution to the problem. First thing we need to find is integral m dx, where y is constant. This is equals to integral m x cube plus xy square minus a square x into dx. So as we said earlier, y is constant, right? Here y square, a square are constants, and we can write the integral as integral x cube dx plus integral xy square dx minus integral a square x dx. Since y square is constant, so we'll write this y square outside the integral, then we'll get integral x cube dx plus y square integral x dx minus integral, here a square is constant, right? Let's write a square outside the integral. You'll get minus a square x dx, which gives us x power 4 by 4 plus y square into integral x dx is x square by 2 minus a square into integral x dx, x square by 2. Or we can write this as x power 4 by 4 plus x square y square by 2 minus x square or a square x square by 2. Let's now find LCM of 2 and 4. LCM of 2 and 4 is 4, right? In the first term of, the denominator of first term we have 4. So close 4, we have nothing to multiply to this numerator. So just write x power 4 plus in the second term, in the denominator of second term we are having 2. So close 1, 2 and multiply this 2 to the numerator. You'll get 2x square y square minus the third term of the denominator of third term we have 2. So let's cover 1, 2 and multiply this 2 to a square x square. You'll get minus 2a square x square, right? Therefore, integral m dx, where y is treated as constant, is equal to x power 4 plus 2x square y square minus 2a square x square by 4. Now coming to second one, integral n terms of n free from x into dy. So the terms which are free from x in n is minus y cube minus b y square. So let's take minus y cube and minus b square y in the integrand. We'll get minus y cube minus b square y into dy. This is equals to minus integral y cube dy minus integral b square y dy, which gives us minus, let's take the constant outside the integral constant, which is minus b square integral y dy. This is equals to minus integral y cube dy is y power 4 by 4 minus b square into integral y dy is y square by 2, which is equals to minus y power 4 by 4 minus b square y square by 2. Now find the LCM of 2 and 4. LCM of 4 and 2 is 4. In the denominator of first term we have 4. So close this 4, you have nothing to multiply to the numerator of first term. Just write minus y power 4 minus in the denominator of second term you have 2, close 1, 2 and multiply this 2 to the numerator. You'll get minus 2b square y square. Okay. Therefore, integral n, that is terms of n free from x into dy equal to minus y power 4 minus 2b square y square by 4. Therefore, the general solution is given by integral m dx, where y is treated as constant, plus integral n terms of n free from x into dy equal to c. So the result obtained from the first integral is x power 4 plus 2x square y square minus 2a square x square by 4 plus result obtained from the second term, from the second integral is minus y power 4 minus 2b square y square by 4 equal to c. Right? You can write this as, just take minus common from these two terms and you'll get x power 4 plus 2x square y square minus 2a square x square by 4 plus of minus of y power 4 plus 2b square y square by 4 equal to c. Right? Or you can write this as, you can just write directly instead of writing these two steps. I mean, instead of writing one step, not two steps, okay? We'll get x power 4 plus 2x square y square minus 2a square x square by 4 plus into minus minus y power 4 plus 2b square y square by 4 equal to c. Since we are having the same denominator, you can write this as x power 4 plus 2x square y square minus 2x square a square x square minus of y power 4 plus 2b square y square by 4 equal to c, which gives us x power 4 plus 2x square y square minus 2a square x square minus y power 4 minus 2b square y square equal to 4 into c, 4c. Since c is a constant, 4 is also constant, or c is an arbitrary constant and 4 is a constant, so we can write 4c as c. 4c equal to c, or write some other c. We'll get x power 4 plus 2x square y square minus 2a square x square minus y power 4 minus 2b square y square equal to c, or x power 4 plus 2x square y square minus 2a square x square minus y power 4 minus 2b square y square equal to c. Okay. So here we have taken minus common, or you can just leave like this. Okay, and write this step directly from this. Okay, you can skip this step. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye.